explain about a project titled A Multipredictor Ensemble Decision Framework based on deep reinforcement learning for regional GDP prediction. So now coming to the introduction part. In the continually changing realm of economic prediction, accurately forecasting regional gross domestic product, which stands for GDP, poses a multifaceted challenge that necessitates inventive methods to improve precision and dependability. An advanced strategy to tackle this challenge entails crafting a multi-predictor ensemble decision framework grounded in deep reinforcement learning. This framework signifies an amalgamation of sophisticated predictive modeling techniques, leveraging the capabilities of various predictors within the framework of deep reinforcement learning to establish a resilient system for predicting regional GDP. So now coming to the objective part for this project is to substantially improve the precision, flexibility and resilience of regional level economic forecast. Conventional approaches frequently face challenges in comprehending the intricate and dynamic connections among diverse economic indicators that impact regional GDP. This framework seeks to address these limitations by harnessing the collective strength of multiple predictors within the context of deep reinforcement learning. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project. Here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and C1 for visualization are important. Second, here we have exploring the dataset GDP India. The dataset related to the gross domestic product of India is loaded and explored. This step includes understanding the structure of the data, checking for missing values and getting insights into its features. Next, here we have data processing, using Pandas data frame, utilizing Pandas for manipulating and organizing the dataset. Second, we have Keras, potentially using Keras, a high-level neural network API for certain aspects of data processing, which could include preparing data for deep learning models. The next here we have visualization using C1 and Matplotlib, creating visualizations based on different columns data using C1 and Matplotlib. Visualization is crucial for understanding the distribution and relationships within the data. Next here we have feature selection. Features are selected and the data is structured by appending it to xtrain and ytrain, where xtrain represents features and ytrain represents labels. The next here we have reshaping the data. Data may need to be reshaped to align within the requirements of the specific model, especially deep learning models. The next here we have building the model. XGBooster. Constructing a model using the XGBooster algorithm. Voting classifier SVC plus RF plus DT. Combining support vector classifier, random forest and decision tree models using a voting classifier. MLP, which stands for multi-layer perceptron, creating a model using a neural network with multiple layers. Then we have ELM, which stands for extreme learning machine, based on elastic net, developing a model based on elastic net within the framework of extreme learning machine. RBF, which stands for radial basis function SVM, building a model using support vector machines with radial base functions kernels. TCN as temporal convolutional network, constructing a model based on temporal convolutional network. GRU as gated recurrent unit, developing a model using the gated recurrent units. RNN recurrent neural network, creating a model using the recurrent neural networks. ESN as equal-state network, building a model based on the equal-state networks. ENN, which stands for extreme learning machine with neurons, developing a model based on the extreme learning machine with the neuron. LSTM, which stands for long short-term memory, it constructs a model using the long short-term memory networks. CNN plus LSTM, integrating convolution neural networks with the long short-term memory. And DBN, deep belief network, DQ and TCN GRU, constructing a deep belief network using a combination of deep Q networks, temporal convolutional networks and gated recurrent units. The next here we have training and building the model. The models created in the previous step are trained using the training data to adjust their parameters for accurate predictions. Next here we have class framework with SQLite for sign up and sign in. Setting up a web application using Flask and incorporating SQLite for user sign up and sign in functionality. Next here we have importing the packages. Similar to the initial step, this likely refers to importing necessary packages for the Flask application. Then next here we have user gives input. User input data for predictions into the application. Then here we have the given input is pre-processed for prediction. pre-processing the user input to align it with the format expected by the trained machine learning and deep learning models. Next, we have trained model is used for prediction. The pre-processed input is fed into the trained model for prediction. And the last one here we have final outcome is displayed through front end. The model's predictions are communicated to the user through the front end of the web application, providing the final outcome of the GDP prediction. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as template. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Next, here we have static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Then we have .ipynb file, which is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next, here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And the last one here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py. And now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browsers. Here I am using Chrome. Just paste the link over here and now hit the enter button. And here you can see that this is our home page for the new Multipredictor Ensemble decision framework based on the deep reinforcement learning for the regional GDP prediction. Here's the button for sign up. Just click on this button and enter your username, your name, your email ID, your phone number, and your password over here for doing the registration. I have already done the registration, so I'm clicking on sign in button. So just enter your username and the password over here which you have created while doing the registration and simply click on login button. Click on OK. And here by scrolling down below, here you can see that this is a form where you have to enter the nominal GDP per capita. Suppose here I am entering 200, for GDP as 54, for the growth rate per capita as 5. And now click on predict button. Here you can see the results. The outcome is GDP is 500 and the status is no change. So depending upon the parameters I am providing over there, it will show you the outcome about the GDP and the status. Here you can see that there is a button for about. Just click on this button. And by scrolling down below, here you can see that there are many different graphs where you can see that we have used many different algorithms over there for getting the accuracy for different algorithms. There is a button for sign out. Just click on this button and you can successfully log out with this. So now coming back to the conclusion part. In summary, the creation of a multi-predictor ensemble decision framework employing deep reinforcement learning for forecasting regional GDP marks a noteworthy progression in economic forecasting. This inventive method, firsting the advantages of ensemble prediction and deep reinforcement learning, has the capacity to transform our comprehension and prediction of regional economic patterns. The framework's noteworthy adaptability, rooted in the principles of deep reinforcement learning, emerges as a pivotal characteristic that effectively tackles the challenges presented by the dynamically shifting economic environment. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.